Hello student, welcome back to the world of electronics paper 1 applied electronics. Chapter number 2 power supply session 4. So already we have seen 4 sessions of power supply. Today we'll be doing session 5. So let us very fast summarize what we have done in previous session. We started with the block diagram of a DC regulated power supply, right? So we have seen in that the blocks transformer, rectifier circuit, filter circuit and the regulator circuit. We have seen that the transformer, there are two type of transformer, step up and step down transformer. In a regulated power supply, we use a step down transformer followed by a rectifier circuit. The main function of the rectifier circuit is to convert the AC, the bidirectional AC into unidirectional DC. So we have seen there are three type of rectifier circuits which converts the bidirectional AC into unidirectional DC. So that is half wave rectifier, full wave rectifier, that is central tap full wave rectifier and bridge rectifier. We have seen the circuit diagram, waveforms and the parameters. Then we have seen the comparison of these three rectifier circuit. Then followed by the filter circuit. The output of the rectifier is known as pulsating DC. We didn't get the constant DC, but there are some AC components, unwanted AC components are there. To remove this, we use a filter circuit. Okay, that is nothing but ripple. We are seeing filters. There are different types of filters. Capacitor filter, inductor filter, then inductor capacitor filter, then the pi filter. We have seen T filter and series RC filter, followed by a regulator circuit. The output of the filter is given to the regulator circuit. In this we have seen need for the regulator circuit. Why we need? After filter we get almost a constant DC. Then why there is a need for a regulator circuit? Then we have seen Zener diode, VI characteristics of Zener diode. Then we have seen Zener as voltage regulator. So we are completed till Zener as voltage regulator. So now in this session we'll proceed with the regulator circuit, that is in session 5. Now let us start with the 3-terminal AC regulator. The, as the name indicates, 3-terminal IC regulator has only 3 pins. These pins are unregulated input voltage, regulated output voltage and ground. Earlier the IC regulator has 8 or more pins that had to be connected in various way. The 3-terminal IC regulator can supply large load current from 100 milliampere to more than 3 milliampere. These are available in metal or plastic package. They are inexpensive and easy to use. Earlier, the IC regulators required many external components, but 3-terminal IC regulator requires only a couple of bypass capacitor. Because of such number of advantage, the 3-terminal IC regulator are nowadays widely used. So instead of Zener diode, 3-terminal IC regulator is widely used in power supply to regulate the voltage. Let us see the block diagram, functional block diagram of 3-pin IC voltage regulator. 3-pin, pin 1, pin 2, pin 3. Pin 1 is connected to the output of the filter. Pin to the output, here we get the regulated DC output voltage, and pin 3 ground. The 3-pin IC regulator consists of a series pass transistor, current limit and the thermal shutdown circuit, the comparator, your op-amp is used as a comparator, and a potential divider network. The built-in voltage reference here is connected to the non-inverting terminal input terminal of the comparator, while the output of the potential, output potential of the regulator is fed back to the inverting terminal of the potential divider circuit. So see, the output is fed back to the comparator circuit, right, through the potential divider network. So the output voltage when the output voltage is more than the required value, so what is our aim? To keep this constant. But if it increases than the required value, suppose we want 5 volt and it is giving us 6 volt, so that is the more output voltage. Then what happens? Where than required the value, then the input potential of the comparator is also more. So see, if more voltage will be fed back than the V reference. So here it compares and therefore the output of the comparator drops, because see here more, this is negative and this is positive, so output will drop. ये increase हो गया और ये decrease come, so output will drop, and keeping the output voltage constant. Now reverse, when the output of the regulator is decreased, agar V out decrease ho gaya, then what? Then the less voltage will be fed back and output will increase. The output voltage of the comparator will increase, keeping the output voltage constant. Okay. The output voltage of the comparator is applied to the series pass transistor as per the output conditions. The comparator drives the series pass transistor heavily or moderately. So here we are supplying the voltage to this series pass transistor, so this will maintain the output voltage constant. Okay, will be drive heavily. The series pass transistor will be drive heavily or moderately. Thus it means that if the output voltage increases, it drives the series pass transistor moderately, and if the output voltage decreases, then it drives the series pass heavily. This series pass transistor can handle more than 1.5 ampere load current. Now, the thermal shutdown and the current limiting circuit does not allow to damage the IC, because very high current is flowing. The thermal shutdown circuit is used to make IC automatically off when the internal temperature of IC becomes dangerously high, that is above 175 degree Celsius. The current limiting circuit does not allow to increase the load current than its rated value. Because of this, because of this block, the life of the IC increases. Okay. So because of this, the life of the IC increases even though we provide the heat sink to the IC. Clear? So this was the block diagram of 3-terminal voltage regulator. Types of IC voltage regulator: fixed voltage IC regulator and variable or adjustable voltage IC regulator. So there are two: fixed, which value cannot be changed, and variable, according to our requirement we can vary the value. So there are two type of IC regulator. Fixed voltage IC regulator. See here, LM340 series is used as 3-terminal voltage regulator. Okay, for this, see, 340, pin 1 is the input. So pin 1 is connected to the input. The input comes from the filter output. The fixed voltage regulator has an unregulated DC input voltage V in applied to the one terminal of the IC, a regulated output DC voltage V0 at pin number 2, that is second terminal, and the third terminal of the IC is ground. LM340 X means 5. If here it is 5, then has an output voltage of 5 volt. If it is 10, it will be an output voltage of 10 volt. Okay. So when the IC is near the filter capacitor of an unregulated supply, this leads the inductance and may produce the oscillation. So Now the unregulated may produce the oscillation. This is avoided by using a capacitor. So we in additional we require two capacitors C1 and C2 which are connected on pin 1 and pin 2, right, to improve the transient response of the regulated output voltage. The capacitor values are from zero point 0.1 to 1 microfarad. Any device of LM series need an input voltage at least 2 or 3 volt greater than the regulated output voltage. If you want 10 volt constant output, then you have to take 14 or 15 volt regulated IC voltage. So this voltage of the IC should be greater than the required output voltage. Otherwise it will stop regulating. This is called as brownout. Okay, so we have to take, if for example we are taking LM 345 volt, so needs the input voltage in the range of 7 to 20 volt. Okay, this is the maximum limit to the input voltage because of excess power dissipation. So if we are taking 5 volt, so the input voltage should be 7 to 20 volt. Otherwise it will stop regulating. Is it clear? Application of fixed regulator voltage. It is used to provide fixed DC voltage to sensitive electronic circuit as the load source to provide a voltage current regulation. So as a current source to provide a load current regulation. LM 340 series regulates positive output. So it gives us the positive output, and LM 320 regulates negative output. So if you want negative output, so you have to use LM 320 series. The fixed output voltage regulator for regulate for 5 volt, we get 6 volt, 8 volt. This all ICs are available if you want these outputs. Okay, 24 volt as the adjustable voltage regulated by a using. So this can be adjusted by using a variable resistance at the output. Clear the application of the fixed regulator IC. So the next type is, so we are seeing fixed type of voltage regulator. Now adjustable voltage regulator IC. So voltage regulator are also available in the circuit configuration that allow to set the output voltage to the desired regulated output. So here we can adjust the output voltage as per our requirement. So here LM317 is used. So positive input, again it is a 3-pin IC. Input positive pin 1, output pin 2 and 3 ground. Okay, so here adjustable, see here, now there it was directly connected to the ground, here it is connected to the filter, and here we have a potential divider circuit. Clear? So this is the ICC. It is provided with the heat sink. This metal part is called as heat sink. Pin number 1, pin number 2 and pin number 3. Pin number 1 is connected to the filter output. Pin number 2 we get a regulated DC voltage, and pin number 3 is connected to ground. Is it clear? So you have to draw the diagram of LM317. So by using a potential divider arrangement, we can use the IC for variable, that is adjustable voltage regulator. The ratio of R2 to R1 decides the value of the output voltage. So this decides the value of the output voltage. So here we are using a pot. This R1 is fixed, R2 we are connected a pot so that we can vary the output as per our requirement. In this circuit also two capacitors are used, C1 and C2, for the use for stability. It provides good voltage and right regulation and ripple rejection. So we have in our lab we have made the power supply using LM317. Okay, during the practical I will show you the diagram. We'll see the IC how it is connected in the power supply. Okay, let us find the expression for the output voltage in terms of R1 and R2. So I1 is a current in R1 and I adjust is the current from the pin 3. Okay, So what is V out? V out is equals to total this, right? So current flowing through R1, that is I1, and current flowing through R2, that is I1 plus this current. Two currents are flowing, I1 plus I adjust. So V out is equals to I1 R1 plus R2 into I1 and I adjust. But what is I, I1 equals to VR, that is V reference voltage upon R1, and VR is equals to V reference. Substituting this value in the equation, what we get? VO is equals to IR, I1 R1 is equals to VR plus R2. Again I1 is equals to VR upon R1 plus I adjust. So from these two terms we can take VR common. So we taking VR common. So 1 plus R2 upon R1 plus R2 into I adjustable. I adjustable is very small. It can be neglected. So we will be neglecting this. So what we got? V out. V out is equals to V reference. So V reference is kept at 1.25 volt and 1 plus R1 R2 upon R1. So this is output. So by varying R1 and R1 and R2, we can adjust the output voltage as per our requirement. So we will keep R1 fixed and we will vary R2. Clear? So the voltage regulator also filters the input ripple, and therefore there is no need of RC or LC filter. So instead of filter, this can directly be connected to the rectifier output. Okay. Of variable regulator. It is used in laboratory where different value of the output is required. So in our lab also we have variable regulator circuit. We'll show, and you have to perform one practical based on this. It can provide wide range of output voltage from 1.25 volt to 24 volt. It is also used to the speed control of DC motor and DC fan. Clear? So these are the application of variable regulator. Now student, let us see the problem. Sometimes the problem comes on LM317. So let us see the problem based on that. Calculate the range of output voltage obtained with the diagram given. So you are given the diagram and you have to find the range what output will get. So here what we have, 250 R1 and R2 is 500 and a pot is connected of 4. So while finding the minimum, we will consider only 500 ohms, and for R maximum we will take both series, so 500 plus 4K. Clear? And we will find the output voltage for both the cases. So we want to find the range, the minimum range and the maximum range. So what is the formula? Output V out is equals to 1.251 plus R2 upon R1. So R1 is 250 ohms, R2 is 500 ohms, R2 maximum is 500 ohms plus 4K ohms. So here minimum voltage equals to 1.25 R2 upon R1 plus 1. Substituting the value of R1 and R2, we get 1.25, 2 plus 1, 3. So we got 3.75. So our minimum voltage output will get 3.75. So let us find now the max. We have found out V out when R2 was equals to 500. Now we have taken 500 plus the series resistance, that is 4 kilo ohm. So R2 maximum is equals to 500 plus 4 kilo ohm, that is 4000 ohms. So substitute in the output equation. So what we get? V out is equals to 1.25 500 plus 4000 upon 250, that is R1 plus 1. So V out is equals to 1.25 into 18 plus 1, that is equals to 23.75 volt. So the range of the output voltage is from 3.75 volt, that is when R2 is equals to 500 ohm, to maximum, that is 23.75 ohm. So it will vary from the output voltage, we can vary by varying the potential from 3.75 volt to 23.75 volt. Clear? So by just varying the potentiometer, we can get the variable DC output. So simple, just we have to substitute the value in the formula. Clear? So here we came to the end of the session. So let us see. So we have seen in the last session as a zener as voltage regulator. In today's session we have seen the ICs, the 3-pin IC as a voltage regulator. We have seen the functional block diagram of the 3-pin IC voltage regulator. Then the two types of voltage regulator IC, a fixed voltage regulator circuit and a variable regulator IC circuit. In fixed type, we have seen that if you want LM series 340 to get the positive output, and if you want a negative output voltage, DC voltage of fixed type, we use LM 320. So, and different fixed type voltage output voltages ICs are available from 5 volt to 24 volt, both in positive output as well as negative output. Then we have seen adjustable voltage regulator, where by varying the resistance we can adjust the DC output voltage as per our requirement. So that series was LM317. Based on this adjustable LM317, we are going to perform two practicals by varying the load. So how we can change the output as per the our desired, and even though the output load is varied, then also the voltage DC output voltage remains constant. So we will be performing two practicals based on this regulated IC, that is LM317. So here student, we came to the end of the power supply session 5. Thank you.